Evolution. This is very similar to what you learned in bio if you had me as a teacher. So give me a definition. Genetic change. Period of time within a population. Good. And so you know, and I always add this and I never add it to my notes, reproduction must occur. Because if we're genetically changing over time within a population, then there's reproduction, obviously, and transfer of genetic material. We study microevolution in this class, or that's our focal point, even though there's really two main groups, which is micro and macro. Who could tell me the difference?
Macro's big picture, so it's going from like apes to humans.
Okay, good. Which one of these diagrams helps you see that?
The one with the dinosaurs.
The one with the dinosaurs. And on here in this picture?
Micro.
Over here, look at this.
Macro.
Which one?
The one that's going up.
The one that's going up, good. Because you're going from lizard to bird, so that's macro. And what's happening to my lizards in micro? They're becoming different. They're changing shape, color. So it's a genetic change, what they call small scale evolution within a same species over time, right? That's the one we're going to focus on in class. So who's the father? Darwin. Is he here? Yeah. And tell me about him.
He went to the Galapagos Islands.
He went to the Galapagos, which is where?
Off the coast of South America.
Good. Off the coast of South America. And did what?
He studied birds. Finches.
Finches. More than that.
Iguanas.
Iguanas. Tortoises. And did what? What did he propose? Theory of evolution. Good. Or mainly natural selection. And what did he travel on? The Beagle. Good. And he also wrote a book. Anybody know the title of the book? I should put that.
It's called Series. No.
Origin of Species. So reproductive isolation. Think of that word, like dissect that word for me. This is a type of evolution occurs because of this.
Certain species are only available in certain areas.
Good. That's exactly what it is. So you're kind of limited to your reproductive potential. So it prevents members of two species from mating or producing offspring. And that results from being, all these terms are correlated. And you can have them individualized. But at the end of the day, if you're geographically isolated, that means you've been separated due to geography. And it could be a natural occurrence or even man-caused, right? Behavior. Maybe you just don't, and there's so much, like right here. No, our mating sites are different. That's geographical isolation. But maybe you don't like the way an organism looks or their call is off. So that will eventually lead to lack of reproduction. Does that make sense? All these words are kind of correlated. So whenever you see these words, you're thinking of descriptions as to how reproductive isolation occurs. That's what I'm trying to say. And those are barriers in a sense that cause it. Here's a little bit more about geographical isolation. And when organisms in a population obviously are separated due to some natural or, like I mentioned before, man-made cause, it prevents the group from exchanging genetic material. So that's just a picture to kind of reiterate what I just said. So speciation will basically lead to the evolution of a new species. And unfortunately, you have to know these words. But if you look at the picture, they are associating this specific type of speciation that results from what? Look at the picture, what's happening from here to here. Of what kind? Geographical, right? Because you're seeing a separation in where they live, so they can no longer come together. And then sympatric speciation will result from something other than geography. And then I'm only referencing here 2 pictures, but you also see here, there's another type, And unfortunately, as much as I want to say you don't have to know those, you do. They all mean the same thing. I'm stopping.